How does an AI look at a dataset with 1,000 columns and actually see it? It photographs it from the best angle, turn it far enough, and the mesh suddenly separates into three groups, three species of flower that nobody labeled for it. Here is a real dataset. 150 flowers, 4 measurements each, the length and width of two kinds of petal. There are 3 different species in this table. Can you see them? Neither can I. 4 numbers per flower is already too many for a human eye, and real AI data has thousands. Photograph a chair straight down the back and it is a stick. Move round to the side and you see a chair. The object never changed. You just found the angle that showed the most. That is the whole idea. Take just 2 of those measurements so we can watch. Every flower is a dot. First we slide the whole cloud so its middle sits on the center of the picture. In numbers, that is just subtracting the average of each column. Nothing about the shape changes, only where it sits. So which way do you turn? There is a number that answers it. Now, the only question that matters. Which direction does this cloud stretch out along the most? Try one. Measure how spread out the dots are along it and watch the number. Turn the line. And the spread rises, peaks, and falls away again. The angle where that number is biggest is the answer. That line is the single direction carrying the most information in the whole dataset. People call it the first principal component. It is just the direction of most spread. The name is the hard part. Once you have the best direction, the second one is forced. It has to sit at right angles to the first. And among all of those, it takes whatever spread is left. Keep going and you get one direction per column of the original table. Always perpendicular, always in order of how much they carry. Here is that same data drawn against 2 of the original measurements. A smear. You cannot honestly pick out 3 groups in that. Now swing around and draw it against the 2 directions we just found instead. Same flowers, same numbers, nothing added, and there they are. 3 species sitting apart, discovered by something that was never told they existed. And here is what it cost. The first direction alone carries 92.5% of everything moving in this data. The second adds 5.3. Together 97.8%, and the last 2 directions hold almost nothing. So you throw them away, keep 2 columns instead of 4 and lose about 2%. 4 columns is not 1,000 though. Let us actually earn the title. 4 columns is not 1,000. So here is a harder one. Real handwritten digits, each one an 8 by 8 image, which means 64 numbers per digit and no way at all to picture that. Run the exact same 4 steps. Center it. See how the columns move together. Take the 2 directions of most spread and draw 1700 digits against them. 64 numbers down to 2 and the digits still sort themselves into groups. Nobody told it what a 3 looks like. And here is the honest bit. With the flowers, 2 directions held 97%. Here they hold 28. You are throwing away most of it and the structure survives anyway. You do not need most of the data to see what it is doing. Flowers and handwriting are fine. But here is the data an AI really carries around. 60 real words, each stored as 50 numbers, the kind of word vectors a language model is built on. 50 numbers each, completely unpicturable. So run the same 4 steps and draw them on the 2 directions of most spread. And the space sorts itself out. Kings and queens together. Family words together. Cities sitting right beside their own countries. Animals off on their own. Nobody grouped these, the geometry did. And this is where the season closes a loop. Episode 1 said meaning becomes geometry. King minus man plus woman lands on queen. That still works in the full 50 dimensions. PCA is simply how you get to look at the space where it happens. A pancake sitting in the air is a 3-dimensional thing, but it is almost flat. Press it onto the table and you lose the thickness and keep everything that mattered. High-dimensional data is nearly always a pancake in disguise. And now the part that ties the whole season together. Every step you just watched already has a name from an earlier episode. Written down it looks like this. And if that means nothing to you, it genuinely does not matter. It is only shorthand for measure how the columns move together, then find the directions of most spread. You already understand it. One thing before the code, because almost every explanation skips it. People say PCA finds the best features. It does not. It maximizes spread, and it is never told which flower is which. Spread and usefulness are not the same thing. On this very data set, just picking petal length and petal width pulls the three species further apart than PCA's own answer does. PCA had no way to know that mattered. Use it to see your data, not to decide what is important. 4 lines, and it is the 4 steps you just watched. Center the data. Measure how the columns move together. Find the directions of most spread. Draw the data against the top two. The full notebook on real iris data is in the description. And that is the season. Vectors carrying meaning. Matrices bending space. The determinant, the dot product, rank, change of basis, eigenvectors, the SVD, low rank, and today all of it at once. Every box on that map is a tool the later seasons reach for. You now have the whole toolbox. Thanks for watching and keep exploring. Please like and subscribe ThirdEye Labs if you enjoyed this video and let me know in the comments.